slight difference, slight difference though in how it's set up, because you have this store that's 300 by 165, and this store had an original parking lot that was an extension of 75 feet from each of those measurements. And so this was the original parking space. And what you want to do is you want to figure out if you want to double this parking lot by expanding it even further. So we expand it x in each of those dimensions. Okay, so that this new part, the part that's black and green together, is double the original. So it's double what the area of the green is. And so there's a couple ways that you can approach this. Probably the easiest one is to simply think, if you double something, so if we were to double the size of this green, then that means, how does the black region have to relate to the green? They have to be what? Equal, right? If you double something, so if you have $1 and you want to double it, how much more do you need? Just another $1, right? You just need the same amount. So if we can find what is the area of this green region, double the, and set that equal to the area of this black region, we'll have our equation to solve for this value x. Okay. So let's take a look at how this relates. So what we can do here is we can cut off this green region into two shapes with easy to identify equations, so both rectangles. So this first one is 75 by 300 plus 75, so 375. So there's the dimensions on that lower part. And then we also have this upper part to this green parking lot, which is the dimension 75 times 165. Okay, so there's our given area, 75 times 375 plus 75 times 165. So we want the new black region, that black area, to be the exact same measurement. Okay, so let's take a look at what we can do with this region. Again, breaking it up into similar pieces. Okay, so we have one rectangle that's x width and a length of 300 plus 75 plus x. So 375 plus x. So x times 375 plus x. There's one of our rectangles. And then to this, we're going to add this other rectangular region, which is x times the quantity 165 plus 75. So this is plus x times the quantity 165 plus 75. Okay, and so here is our equation. If we solve this equation, we should be able to find x. We can use the solve feature on our calculator. And so if we enter that in, F2 algebra tab, solve, and then just calculate what we have. 75 times 375, add that to 75 times 165. Okay, and that has to equal the area of this orange, or this black region, x times the quantity 375 plus x, all plus x times the quantity 165 plus 75. And then I'm going to close that off, solve for x, and when I do that, x is equal to either 60 or negative 675. Can we have a additional length of negative 675? No, so that's the extraneous solution again. Okay, and so the extension is by 60 feet.